Number 26. On a day in June 2017 on Staten Island, the function t of h is equal to 8 sine pi over 12h plus at was used to model the temperature T in degrees Fahrenheit 8 hours after 9 a.m. State the value of t of 6 and explain its meaning in context. So the first thing I'm going to do is actually figure out what 6 hours after 9 o'clock is. So 3 hours would be 12, and then another 3 would be 3 p.m. So basically, when I plug in 6, I'm going to find out what the temperature is at 3 p.m. So let's plug in 6 to our equation. So we know our equation is right here. So I'm going to plug in 6. So we have 8 sine pi over 12 times 6 plus 82. Now, if I do pi over 12 times 6, that's going to give me pi over 2, or 1 pi over 2. Now, if you remember, the sine of pi over 2 is really the sine of 90. I could also just type that into my calculator, and the sine of 90 is 1. So if I draw my sine circle, I'll see that sine is 1. And then when I simplify that further, I get 90 degrees. So remember, you could just type this part into your calculator and get 90. Now, that gets us a point. Now we need to explain what this means. So we can basically now say at 3 p.m., it is 90 degrees Fahrenheit. And that's your final answer. Now, if we look at question number 27, it says use the properties of exponents to show why negative 64 to the 2/3 is equal to 16. Well, if you watched an earlier video, you should remember that the number at the top of our fraction is our exponent, and the number at the bottom is our root. So what I'm going to do is rewrite this now as the third root of negative 64 squared. Now, instead of squaring negative 64, because that's going to give me a super big number, I'm just going to take the cube root and then square it. So I'm going to ask myself, what are two numbers that multiply to 64? Well, that is going to be 2 and 32. So I circle my 2 because it can't be broken up. Now I try to break apart 32, which is 2 and 16. Then I break apart my 16 to be 4 and 4. I could also do 2 and 8. But we know to make 4s, we break those up into 2 pairs of 2. So now I'm going to write down 1, 2, 3, 4, 5, 6. 6 2's underneath my radical. So I'm going to have 6 2's. Now, we want to take out groups of 3. So when we take out groups of 3, those 3 2's become 1 2 on the outside. Now here's the issue. It was the cube root of a negative 64. That means it's going to be a negative 4 when I simplify it. Because 2 times 2 is 4, but we want to take the cube root of a negative, so now it's going to stay negative. Now the thing is though, when we simplified, we got negative 4. We want a 16. So now what we have to do is square our negative 4. So let's square negative 4, and then negative 4 times negative 4 is 16. All right, let's look at question number 28. 28 says graph y equals 2 to the x minus 2 on the set of axes below, and then state the equation of the asymptote. Before we go any further, we can actually state the asymptote by looking at our equation. It's always the number hanging out by itself. So in this case, my horizontal asymptote is y equals negative 2. So what I'm going to do is now just draw a dashed line at y equals negative 2. And then I'm going to use my calculator to graph this. And you're gonna want it to look just like how your calculator looks. I'm gonna hit graph and it needs to look something like this. So now I'm gonna hit second graph. At 0, I get -1. Plot your nice points first. At 1, I get 0. At 2, I get 2. At 3, I get 6. At 4, I get 14, which is gonna be off my grid. At -1, I get -1.5. At -2, I get -1.75. So if you notice, I'm gonna get super close to my purple line, but not touch it. So now just be very careful when you're sketching it. And then it's gonna go through these points and then come very close to our line, but not touch it. And that's gonna be number 28, the equation of y equals 2 to the x minus 2 when sketched.